Aber wenn man so, da wurden ja 2000 einfach von der Netz gelaufen und also nicht ganz G20 Ausmaß, aber
What we know in a class C network is IP addresses. What in a class C network? Address. You know the answer? Hold on after this guy. Okay, now it's your turn.
But der Question ist gesagt, ob network.
How do you recognize, looking at an address, how do you recognize this is a class C address?
Either you have a subnet, like x720, or you can look at the subnet path.
If you didn't see the mask, you just saw the IP, the number.
Then it's like
It says 200.7.3.1.
Then if on the number converted to binary, you just can count ones, or you can go, I don't have.
Okay, and the other number is. Okay, thank you. So you look at the first number on the left of the IP address, or look at its decimal or binary value. And if it's binary, then the first two bits will be 1 and then the third bit will be 0. Which one is the larger network? Network class A or C? Class A. It has about 16 million addresses in it. Right. Give me one difference between IP address version 4 and version 6.
On version 4, there are 4 digits separated by your dot, and version 6, they are separated by a semicolon.
Separated by colon. Okay, give me another difference between IP4 and IP6.
IP6 is right in hexadecimal, and IP4 is in inch.
And the other one is in octet.
No. Numerical.
What did you say? Okay, IP6 is in hexadecimal, and IP4? Decimal. Or they're both in binary. Right, okay. Which one provides unicast? IP4 or IP6? What do you think? Both. And which one provides anycast? IP4 or IP6? Both. Wrong answer. IP6. What's unicast? No, not unicast, sorry. Anycast.
Capacity of sending message one device between maybe
One in a selected one in a group of devices, one of many. Okay. How many devices can be connected to a class C network? It's a good answer. That's not the right answer. Class C network, is it a big network or a small network? A very small network. What's the maximum number of devices can be connected to it? Exactly. Yeah. Correct. 256 is the total number of addresses, but 254 is the number of devices that can be connected. Why? What's the first address used for in a network? Oh, it's a good one, but it's not the right one. The network ID. It identifies every network has a number of addresses. The first address is always used to identify the network. And the last address is used for a broadcast. Yeah?
I've read before that the first address is the gateway.
Not necessarily. It's to be recommended to put the routers on the first ones, but it's not a rule. It's not a requirement. But for even a router inside that network, it cannot take the identifier for the network. So, but if you have, for example, a network, most networks will have 2 or 3 or 4 routers, they always give the routers the first address in the network, and then the rest of the devices. Okay, any more questions? You have any questions, guys? All right, then we better start subnetting. All right. Have we started recording? Okay, sit down, guys, and enjoy the ride now from now on. I'm going to show you 2 ways to subnet. First way is just a temporary one. Just want you to get the concept. You have to understand a couple of things in it, and then we get moving to the real one. Oh, you can't see this. Come on. What am I not doing right here, guys? I found duplicate. Yeah. Okay. Subnetting. So subnetting is taking a network, guys, and splitting it into many networks. It can be 2, it can be 4, it can be 200 subnetworks, smaller networks. Okay, we discussed advantages of subnetworking earlier. Anybody can give me one advantage? Why should we split our network into smaller networks? Any idea why it's a good idea to split, to do subnetting? Maybe for security. I didn't just hear the word you said. Maybe it's right. Yeah, anything else?
Organization.
Yeah, easier for organizations, especially big organizations, better to divide them, and security.
If you want to broadcast, like broadcast with many devices.
Yeah, well, that will improve performance. Improving performance. So instead of broadcasting to everybody, either for security reason you want to only broadcast to individual groups, or if you broadcast to everybody, that'll make it really slow, because every time somebody wants to talk, they have to wait for this broadcast that goes to everyone. So by splitting them in separate departments, every little department can broadcast to itself, will not slow the others. So there are many reasons why subnetting is good. And subnetting is basically taking a network like this and splitting it into smaller sections. Could be 2 networks, 4 or more, any number of networks we want, usually doubles of 2 or multiples of 2. A router is used to separate a local network from another local network. So it looks like we have 2 local networks. That's the general idea. It's like we have 2 separate local area networks, but they're not exactly separate local area networks, so they call them subnets. So division of the same network. But in fact, they act, when they want to communicate with the other one, they act like they are on a separate network, the individuals. Now, remember, if you're in a local network, if you're in a local area network and you broadcast, your broadcast goes as far as the router. It doesn't go any further. You can't broadcast beyond the router. So again, if you split your network into 2 networks, a router is used to do the splitting. So it's the one that isolates the 2 subdivisions or the 2 subnets. But this is where, if this guy broadcasts here, it will go as far as the router and stop. The broadcast does not go beyond the router. So it's like 2 separate networks, even though they are strongly related by the address. So they all belong to the main root address, and they branch into smaller subnets. Okay, so subnetting, all nodes in a segment see all packets. And that's a question that sometimes comes in the exam. You're given 2 IP addresses. Imagine that IP address on that machine and an IP address on this machine. And they say, these 2 machines are having problem communicating or listening to one another during broadcasts. What could be the problem? So you have the 2 IP addresses, you split the network and see where each one of them falls. If they fall in the same subnet, there's a problem. But if they fall in 2 separate subnets, well, that's normal. You can't hear each other's broadcast because they're not on the same subnet. So only if they are in the same subnet, you broadcast and everybody can hear you. But if they're on a different network, then that could be a problem. So that's the question comes in. You just asked basically split it and see where each one of them falls. And if you see they fall in 2 different subnets, then that would be the reason why they cannot hear each other's communication. Okay, so they're done for multiple reasons. Are we repeating what we did yesterday? Why go for a subnet? Yeah, there are many reasons. So we'll skip all this. And we talked about a mask. And what's the purpose of a mask? What's the main function of a mask? Let's see. Any idea what the purpose? I'll come back to it. What's the purpose of a mask? What's a mask used for? Yeah?
It's supposed to isolate the host address part from the IP address and to retrieve the server IP address.
The network. Yeah, so it hides the mask. The main purpose of a mask, when it's put on top of an address, it hides the node address or the server's address or the host address, the device address, and leaves the network address only, reveals the network address. routers always want to see the network address in order to deliver a packet through the network. See, in IP4, in the classful, what they call the classful division, when IP addresses were divided into classes, they were easy to see. This is class A, class B, class C. But when they removed the classes, and they called it the classless addressing, now the router doesn't know which part. It used to be 1 byte or 2 bytes or 3 bytes, that's all. And you know it from the start of the address, the number or the bit on the left. But now it doesn't matter. You can have a class A address and you split it into smaller networks. So you don't know where exactly the network or the subnet address. So that's why we always need the mask. It's no longer a clear kind of cut. And what does the mask look like? There it is. It looks like that's one format, binary format, slash format, or decimal format. So it gets either of those three formats. There's the one format, 255.255.255.0. That's a mask. That's 8 ones, 8 ones, 8 ones, and 8 zeros. There it is. That's in its binary format. And that's in its slash format. So we'll be using the slash format. It's easier, quicker for us to write, but remember what it means. All right, and usually, okay, we already looked at that. If you have any address and you want to remove the host address and just keep the network address, take the mask, add them together, and the result will be the network address. I want to jump straight into the subnetting. I don't want to waste too much time. Or maybe I think we got to this point here yesterday. Right, so what do we mean by subnetting? Subnetting, you take a network, split it into smaller networks, and now we used to have this part represent the network address. Now we also have another part, a number of bits that represent the subnet address. You need to identify those smaller divisions, those smaller networks. If you split a network into two parts, you need to be able to identify, and we give them numbers, 0 and 1. If you split a network into two halves, you need to identify one of them as half 0, the other one is half 1. And therefore, you need one bit to take an extra bit. You cannot touch the original addresses, class A, B, or C. They cannot be changed. They belong to the internet. The world knows you by that number. It's internally. This is like a city code in telephone numbers. Internationally, they give you a code for your country. Let's say Ireland is 353. Internally, you want to put a city 1, city 2, city 3, that's up to you, whatever you want to do. So this is like now the internal division that we're going to have. But the world outside does not know it. It does not recognize it. But internally, for us, for our own communication. So if you take a bit, let's say originally, this class C network, whatever number it is, it has 256 addresses, 254 machines. If you take one bit and you have it 0 or 1, you can say, okay, 0 represents this half and 1 represents this half. So that identifies which subnet, if we split it into two subnets. And the rest of the numbers, then you'll have less in each one subnet. Originally we started with 256, but if you take one bit, you're left with 128. So each half will have 128. They're not really losing much. We just split it right in the middle. It's like, for example, you have one big class here, 100 students, and you have one class rep. We split into two halves, 250s, and now we need a class rep for each one. So that's kind of that's what we use to identify which network are we talking about. And there it is. This is the same example. It split it into 4. Now, how many bits do we need to represent 4 items? We need 4 bits. We need 0, 1, 2, or 3. In binary, 0, 0, 0, 1, 1, 0, and 1, 1. So we need to take 2 bits out to represent the individual. So the more you want to divide it, the more bits you need to identify the division. So let's try this. We have a network, and you are asked, divide this network into 10 subnets. First, let me remind you, we cannot divide it into 10 subnets, right, immediately. They're not 10 equal subnets. We can eventually, but I'll show you other techniques. But we can split a network into 2, and every 2 we can split each into 2 further, so 2 or 4 or 8 or 16, and so on. So now it says, split this into 10 networks. All right. Here's a simple, quick technique to make the division, and tells you how big each. These are going to be equal kind of divisions. What I want to do in 20 minutes is to have different size divisions. But let's just look at this simple one first. First, get the IP address. If you are given, if you are told, divide our networks into subnets, make sure you have the IP address for that network. And how many machines does it have? How many addresses it actually has? So an IP address, and find out the mask, the original mask as well, and find out the number of subnets required. How many subnets do you need? Once that's established, determine the number of bits needed from the original mask. So you have the original mask, and then you say, okay, I'm going to split this network into group, maybe 4. How many bits do I need to represent the number 4, so I can identify each one of them, which is 2 bits. You can write 4 numbers using 2 bits. But if you want 8 networks, then you have to add another bit from 0 to 7. You number them from 0 to 7. Anyway, we'll get to see that. And then make up the new mask for this network. So once you split it, then the mask changes. Now you're going to have subnets. Find the number of increments. Find how big each network is, the chunks of the network, how many addresses are going to go. Normally, for example, you have a class C network that's 256 addresses. I say split it in 2, they're going to be 128 each. Split it into 4, they're going to be 64 divided by 256 divided by 4, they'll be 64 each. Divided by 8, they're going to be 32 addresses each, and so on. So that's what we mean by how big each network is. Later on, we can join 2 of them together to, to have different size. So it's easy enough, but let's now go for the easy way, split in halves. We're going to split into equal size. And then for each one of them, define where does it start from and where does it end at, each network or each subnet. Let me just jump to, and I should have had it here. Right, for example, just for example, you had this network, some network that has 256 addresses. They start at number 0, the maximum is 255. This is class C. It could be another class B and have thousands of addresses. But we work with the smaller one for now. If I say split it into 2, you go right in the middle, whatever the middle is here, 128. So 128 will be the first address of this network, 127 will be the last address for that network. And something like, well, just forget now about the /24. Now, that's if we split it into 2 halves. So one network starts at 0 and at 127, the second network starts at 128, 255. This is really what we are trying to do. We say, no, split it into 4 networks, 4 subnets. Then that's the way it goes. So there's nothing magic about it. It's just you have all the numbers, you just split them at the moment. So that if we split it into 4, that starts at 0 to 63, 64 to 127. The next one starts at 128 to 191. And if we do intend to split it into 4 networks, then that's then the last stage there would say identify where's the network identifier. In any network identifier, the first address is the network identifier. Now, to give those addresses to machines, you can't give any machine number 192. 192 is the identifier for the fourth subnet. You can't give any machine on this network the number 128. 128 will be used as an identifier for this group, for this network, and so on. And you can't also give them 191. That's the last address in this group. That's anything, any packet that comes in with 191, it will be broadcasted to all these machines here. Okay, so that's the general idea. You have a long list of addresses, you split them into as many, and later on, we can have variable size networks by joining these two to make them one bigger network. So that's really how it works, but we'll go through it step by step. Actually, it's easier than this, but just so you get the overall concept now. And you keep going, so if you want to split it into more, you can just keep on splitting. You get to a point where split into two small networks. But if the network was much bigger than this one is the smallest network we took, class C, 256. But if you go for the thousands, then you can split it into 100 different networks, 128 different networks, and every network can have a few hundred machines. But let's work with the smaller numbers to get the concept right. So if I say split it into 8, here is it, well, it's 8, 2, 4, 6, 8, yeah. So that's the way it's going to be. So let's go back, just so you know there's nothing strange about it. Just you have all the numbers, split them as many times as you want. And then establish what's the first identifier. The first address becomes identifier for that sub, and the last address becomes the broadcast for that sub. So here's the example we started with. These are the steps, and find out, okay, so we'll start first. Let's do the steps. First thing it says, get the IP address, the mask can find the number of subnets. Here's the IP address. We're given this IP address, 195.5.20.0 is the address of one network, and we want to split it. What's the mask? It says here we were given mask /24, which means this is the decimal format. That means it has 24 ones followed by 8 zeros. Yeah. So what? Now we're going to split it into 10. That's just what we have and what's demanded of us. We're going to split it. Remember, we cannot split it into 10 equal ones. We're going to split it into 8 or 16, and then the other 8 are not really used. So you could always lose a bit of efficiency when you are dividing subnetting. But anyway, the next one, determine the number of bits. Now, right, they want 10 networks. Now, we want to be able to identify each one of those networks by a number. How many bits do you need? Of course, everything in binary. How many bits do you need to write the number 10? Or up until the number 10. So this is how to write number 10 in binary. 1010. For those who don't know, the number 10 is made up by the 0 is 1. The column here, the first column has the value 1, value 2, value 4, 8. So if you want 10, it's 8 and 2, you put them ones and the others are zeros, and that's how you convert. So you need to be able to do a quick conversion from decimal to binary if you have to. Now, it looks like we need 4 bits just to identify the network. So remember, this part is the network, the original network. This part is the nodes or the hosts. In between them comes the subnets. Now we're going to take 4 of those bits and use them. We always take the bits from the host, from the addresses that are available to users. You cannot change. If this is /24, do not change the 24 bits. Go and play with this. This here, how many do we need? We need 4. So we're going to take 4 of these bits and turn them into 1. And this is going to be our subnet mask. So the original mask is called the network mask. But now we're going to change those 4 zeros there and make it. Note that 4 bits can be used to represent up to 16. Remember, 4 bits can be used to write the number up to 16 numbers from 0 to 15. But so that's where there's going to be a bit of waste. Now, so we're going to take those 4 bits and turn them into 1. And this is now our new mask, our new subnet mask. Okay, we can convert that back into decimal. That's 255, 255, 255, and this number here is 240. You know how it's calculated? That column is worth 1, 2, 4, 8. This one's 16, 32, 64, 128. You add those four numbers together, and that gives you 240. I have a table here. Usually these numbers are always available. You can download them. So this is where we are, somewhere here. We have 4 ones and 4 zeros. That's 240. In slashes, they give it /28. So whichever one, you know, if you will convert it yourself, that's fine. Don't worry, I'll show you a real easy way to do it as well. So, but now I just want you to get the concept right. So we took basically one big network, we split it. We're going to be splitting it into 10 networks. We find out how many bits do we need to modify our mask. And you always think, so the mask bits are in the middle there, the subnets. So this is the net, this is the subnet, and that's the hosts. So each one of those networks is going to have as many machines as you can fit in 4 bits, which is 16 addresses. So now we're going to split, in fact, we're splitting this one single network into 16 networks, not 10 networks, but that's a waste. If they're asking for 10, we cannot. We can do either 2 or 4 or 8 or 16. So we split it into 16, and every one of these networks can have 16 addresses inside them. That's almost the same number, 256. Now you can convert that into binary, and that's our new subnet mask, the new one. This is, okay, so that's decimal, that's binary, and if you want it into the slash format, into 28, that's 8, 16, 24, 25, 26, 27, 28, so /28. Now we got the mask. Once you have the mask, you want to see how big each network is. Okay, there are many ways again to find it, but start at the mask. In any mask you see, any mask you find, start on the right and go until you get to the first one. And see what value is it in this byte. Remember, this is 1, 2, 4, 8, 16. That means that carries the size of the network as well. So that's another quick way of finding out how big any subnet is given a mask. If you're given a mask, just work out your way from the right of the mask until you find the first one of the subnets and give it a value. What value does it have? 1, 2, 4, 8, 16. That means every network here is going to have 16 addresses. Remember, only 14 machines, but 16 addresses. All right, so this is just another quick way of doing it. You'll see how quick it is when you try it once. Now, that means if we start with a 0, we're going to add 16, 16, 16. We keep adding 16. We call them increments or divisions, whatever you want to use at this stage. So remember, we were asked to create 10 networks. We cannot divide 10 networks, divide into 16, and we just found that every one of them is 16. If we had divided them into 8, then each one of them would be 32. And you keep going this way. So I don't know if it makes a lot of sense to you. I think. All right, so now you're going to divide each group and decide what IP addresses are given to each subnet. You start with the original one. The original one is 195.5.20.0. That will be the address of the first one. Always. The address of the first one will start with 0. Class C, that will be 0. Class B, those two will be zeros. Class A, then those 3 here will be zeros. That's the only time that they still relate to the classes. Where is your first address? So the first address is, I'm sorry. All right, so that's the first address. /0. We know the increment. What's the increment here? What size is each one of them? 1, 2, 4, 8, 16. So each one of them is going to have 16 addresses. So this one is going to start with address 0. This one is going to add to it 16. This one, group number 2 or subnet number 2 will start at 16. The next one will start 32. The next one will start 48, 64, and so on. You can keep going. Usually in any example like this, you're asked to do maybe the first 3. What's the first starting address? But you also need what's the last address in the first group. See, this group starts at 0. You know 0 is identifying address, but then it will be followed by 1, 2, 3, 4, 5, 6, up till 16. 16 belongs to the next subnet. Then 15 belongs to this network. It's the last address in this network. In the first one, the last address is 15. So that's the broadcast address for that one. What's the last address for network 3, for subnet 3? So it starts at 32, 33, 34, up all the way to 40, 47, because 48 belongs to the next part, the next network. Okay, so they're all in order, and we split them in equal parts. So you need to know where the first address of each one of them, and then once you know the first address of each one, I mean, the address before it belongs to the one before it, and it's going to be the last one in that network, which is the broadcast for that subnet. So you start, expand them a little bit. That's the first network, starts at 0. The next one is 16. That means the 15 is going to be the broadcast for this one. That's the one before 16. 14 is going to be the last legal address we can give to a machine. So the legal addresses are from 1 to 14. We can give to computers, printers, whatever devices. They can have the routers. They can have addresses from, okay, the same address, but the last number is 1 to 14. 0 is used to identify subnet 2. Let's go to subnet. Subnet 2 starts at 16. What's the first available address, legal address, to give to a machine? 17. There was a question once before. It's okay, you have this network that's split and this address, 195.5.20.31 was allocated to you. You say, is it right? No, it's not right. 31 is a broadcast address. They say, okay, suggest a correction. So give me number 30. Well, any number between 17 and 30 will be legal for computers. Is that okay, guys? Everybody's following me, or you're working on something else? I'm not getting the full response. This is network number 3. It starts at 32. Number 4 starts at 48. That means number 3 ends at 47, the one before this. Okay, I want you to do this example for me now. In 5 minutes, I want you to split this network into a group of networks. 4 subnets. That's all I want. 4 subnets. Okay, this is just the instructions of how to do it. You can split it into. Right, but you can work here. Yeah, you can put that into and share it, please. Share it with that guy, and I'll give this one another one. Okay, this is already in your, if you are looking at the notes, probably it's already on the notes. Okay, can you split that into 2 halves, please? Can you split this into 2? Everybody okay? So follow the steps and do it very quickly. And I want the layout of the first 3, the details, the parameters of a network is always its address, its first legal address, the last legal address, its broadcast address, and its mask. So follow those instructions. If you have a problem, put your hand up and I'll show you how to start. You want a piece of paper, let me know. Okay, so I have that address, /24. So first, identify the mask. You have that formatted, the mask. write down in binary as well, and in decimal, just to show off that you can do it. And how many subdivisions or subnetworks you need? 4. How many bits do you need to take from the host part, and how many does it leave? I can show you how big each half is. If you have a problem, please put your hand up, and I'll show you how to go through this step. But you need to do it quick. We need to go through this. We need to go through the real subnet. All right? I'll give you one. I'll give you a piece of paper. Hurry up, guys. Still nothing. 64. Well, sorry, something like it's the mask for the decimal. There's no, I don't think there's 63. Oh, you have the, maybe I should have given you the other list. How many bits? Okay. First, okay, you're gonna split it into 4 slots. So how many bits do you need for 4 slots? Yeah, so what's the mask? So yeah, those 2 bits would be 1 as well. So yeah, I think you better write in that this mask in line, not before the 2 bits, but this one, write the 8 ones and then move 2 of them, or 8 zeros and write 2 of them, make them 1. So that would be the new mask. So it's 128 plus 64. That's 196, I think. I think it's 196. Anybody's having any problem? Not knowing what to do? You finished? What's the new mask?
New mask would be.
What time would that be? So the first one starts at, what is the other? How big is each level? How big is each group? Yeah, okay, give it a total of this 64. So start from there, you go this way, you start with the first one, that's not the quick way of doing it. In the map, if you go this one, that's one, this one you need. What value is that? 1, 2, 4. Yeah. Okay, so you know what each side is. So what's the first one? Yeah, we said the first address. Now, expand this. The first one, first usable, last usable, and the word. What's the road have to do first? What's the mass? Okay, good. Anybody find out what size each chunk, what we call the increment? You see, first you need to find the mask and then create the new mask. You must create the new mask first. How many bits do you need to represent 4 networks?
We know that it is C.
Yeah, it's true. See the mask says /24. So you should draw that mask. First thing, the first, instruction here, identify the mask. So just write a mask in binary. It's, 24 1 and 8 zeros. And now find out. Now the first 24 you cannot change. The first 24, the first 3 bytes you cannot change. They have to be in the mask. They have to be 1 for 1. That's the actual address.
Yes, the mask is 3 bytes.
Okay, 3 bytes of 1, so you're only using address 80. That's the end. Right. No, but it's better off just program people into what the shape of what the mask is like. And assume they're going to be 24 ones. So please give me the last 8 of the 25. So 8 ones here followed by 8 zeros. They're all 24 ones. Okay. Okay. 1, 2, 3, 4. Yeah. It's easier to identify.
Yes, if I.
So this is the original mask. Now we want to work out the new mask. No. To find out how many bits, you cannot change these. You can only change here. Now the subnet mask will turn some of these zeros into ones. Only this part here in the middle, not the ones on the edge. So this part here belongs to the map, to the host, to the machines. So we're going to take few bits, 1 or 2, 3 or 4, whatever. How many do we need to take? Because how many subnets? 4. How do you write number 4 in binary?
Yes.
We have another 1, 2, or 0.
Yeah. So we do 3. So we have to go those 3 bits and turn them into 1. So the next line is the form is so of those 3 zeros ones. The rest of them are 1. So this is going to be the subnet mask. This is the old mask. This is the new mask. This is the old mask. Now, once you find out your new mask, okay. So the new mask, of course, don't forget the 800. Now, how big is each one of those 8 divisions of 4? It's going to be, in this direction, the first one. So it's up here. 1, 2, 4, 8, 16, 32. So each one of them is going to be 32. Right? Okay, then it's address, that's on 0 there. And then the next one is 52, right? 64. The next time, each one of them, what's the last time? You need to write that. Find the first time that broken out. Why are you doing that? Okay, maybe I'll do it on the board for everybody. Yeah. Okay, up to this point you're correct, right? Now, to find out the increment, we can go this way and stop at this one. So that's the first one we have. What weight is it? What value is it? The first one is 1, the second one is 2, the second one is 4, 8, 16, and therefore every division is going to be 32. Starting at 0, and the next one 32, the next is 64. How are you doing there? It didn't work. Right. Give me a shot. Next time something doesn't, if you don't understand something, right. Now you're going to split this. Maybe I'll do it here for everybody, okay? But guys, make sure you understand it, okay?
First net 0, 0, then 0, 0, 0, 1, then 1, 0, then 1, 1.
Yeah, we're gonna have how many bits?
Represent the 4, the next.
Yeah, 0, 0. Yeah, sorry, you said 3 bits earlier on to represent 4. Yeah, you're right. Excuse me, right? I said, how can you write the number 4? You actually, how do you write 4 in binary? 1, 0, 0. So you need 3 bits. Not how many bits you have. How can you write the number 4? How can you write number 4 in binary? It's 1, 0, 0. So you need 3 bits.
No, yeah, 4 different bits.
Yeah.
0, 0,
No, this here is actually to calculate the chunks, the size of each one. This is the way they do it. It's not how many bits do you need to represent 4 bits or 4 chunks, 4 divisions. You need 64. No, okay, there's something I need. Okay, I need to explain later is that they always leave 2 numbers. They cannot go straight for 4. You need to go for 6. The way they do it here is say, write the number and see how many bits do you need. That's the way they actually work it out. I know you could have used 4, 0, 0, 0, 0, 1, 1, 0, and 1, 1. And that then would have split the network into 64. Yeah, okay. Let me do it here. And let's go through it. There it is. No, that's not the way it is. Let me stop sharing and share again with the. What? Don't send. Something happened here. Did I quit? Zoom quit unexpectedly. Don't send. Just start again. Okay, I'm going to close this and start it again because Zoom stopped.